Okay, welcome to another Ginger Mathematician video with a slightly new format, as you can see, and we're going to go through the Paper 6 investigation part of this particular Paper 6 from March 2021, which is 1 hour and 40 minutes long in total, and it will take us 50 minutes for the investigation part. The total mark is the whole paper is out of 60, but the part we're going to do today is out of 30. Let's get started. So this one is all about enclosed cuboids. And what we're going to do is look at the number of white cubes needed to go around a grey cuboid with integer sides, so with whole number sides. And we're given a diagram to demonstrate what's going on. So we have a grey cube with each edge 1 centimetre long, so it's a 1 centimetre cube. So this is 1 centimetre by 1 centimetre by 1 centimetre. And what's happening here is that we're putting this cube into the middle of this white cube to then make the second cube. So if you can just imagine, in the middle of this particular bigger cube, there is one grey cube right in the middle. And that's going to be our starting point for this investigation. So the enclosing layer of white cubes is 1 centimetre thick. This makes the second cube with each edge 3 centimeters long. So they're talking specifically about this one here. So this is 3, this is 3, and this is 3. And what they want you to do is find the number of white cubes. Well, if we find the total number of cubes here, well, that's going to be 3 times 3 times 3. So working out the number of cubes is the same as finding the volume of this cube. And 3 times 3 times 3 is equal to 27. However, if we want to work out the number of white cubes here, well, we've got one grey cube in the middle. So we just do 27 minus 1, and that gives us 26 white cubes. So if you imagine this cube here, there are 26 white cubes, and then there's one grey cube right in the middle. And now we go on to the second cube is enclosed in a layer of 1 centimetre white cubes to make the third cube. So imagine you've got this second cube here, and we add on an extra layer of white cubes. So for example here, we're going to add on an extra cube here. So I'm going to try and draw this just so you've got an idea of exactly what's going on. So we're drawing in some extra cubes like so. So we should have 1, 2, 3, and you imagine the layers go up, but we also have it on this side as well. So we've also got this idea of another layer of cubes that goes all the way around the outside of the original cube. And what they want us to do here now is write down the length of one edge of the third cube. Notice each layer is 1 centimetre thick as we add it on. So what they're asking for in this particular question is this length here. So if imagine you've now got the third cube, how long would that be? Well, we've got 1, 2, 3, 4, 5 cubes. So the edge length is going to be equal to 5. And once we know that, then we can work out the number of white cubes in this so-called third cube. So imagine now, this is going to be my third cube, so I'm just going to draw a quick sketch of exactly what's going on without actually drawing the individual cubes in. Notice this is 5, so this also has to be 5 because it's a cube, and this is also 5. Remember, we've got this grey cube in the middle, so don't forget that. And we want to find the number of white cubes. Well, to work out the total number of cubes, we do 5 times 5 times 5, which of course you can do on a calculator, but I'll give you the answer here of 125. But remember, the number of white cubes here is one less than this because we have this grey cube in the middle. So we do 125 minus the 1, and that's equal to 124. Okay, now notice this is a 2-mark question here, so they're going to expect some kind of communication. The way I've done this is the working above. Okay, you could have got to the answer more directly by just writing 5 cubed, which is the whole thing, and then minus 1 as well. On to part C, now we need to try and establish a formula for what's going on between the total number of cubes and the number of white cubes. So we're going to write a formula here. So the total number of cubes, so we're just going to explain what we've done in the first two parts of the question, is, well, the total number of cubes is the number of white cubes, and then we want to add on the extra grey cube. Okay, of course, there's only one of those, so then you just do plus 1. So if I'm going to give you a number example of what's going on from what we just did, well, notice the total number of cubes in the third one was 125. The number of white cubes in that example was this answer here, so 124. But then we have to include that one grey cube, which would be plus 1. So this is a numerical example of where I'm actually getting this particular formula from. So the total number of cubes is equal to the number of white cubes, and then we add 1 on. And what we're going to do in the last part of this question is we're going to bring all that information together in the following table below. So N is going to represent the number of enclosing layers, L will represent the length of the outer edge in centimeters, and W will represent the number of white cubes. So all the letters kind of make sense. And we're given quite a few of the details here, so it will actually help us work out what's going on. So let's fill in what we know already. So let's go to cube number 2. So the number of enclosing layers is 2. Well, that was this example here. So the length line was 5. So we're going to write in 5 there. And the number of white cubes for that example was 124. So I'm going to write in 124 underneath. And if we go back one, so we go to just one enclosing layer, that was the very first example that we saw here. And notice that the cube length here was 3, so I can write in 3, which is already there, so that's kind of helpful. And we had the number of white cubes was 26. So this is what we call a non-linear paper. So what I mean by this is you need to go backwards and forwards through the paper so you can sort of glean all the information out of the question. Okay, so let's now think about what's going to go on now. Well, the next layer, or this is going up in 2s. So the next layer is going to have a length of 7, which makes sense because if we add on an extra cube here and an extra cube here, we then get a length of 7. And of course, we just keep adding on 2, then we're going to get 9 like so. Now we need to work out the nth term of this sequence of 1, 3, 5, 7, 9. So we've already identified that it goes up in 2s. And this is very common on paper 6s, the idea of some kind of nth term. So really do prepare this for your paper 6. And the nth term here, well, it's going up in 2s. So it's going to be 2n. And then what do we do to 2 to get to the first number here, 3? Well, we're going to add on 1. And again, you can always check to see if you've got the right nth term here. So if I substitute in n is 3, for example, well, 2 times 3 is 6, 6 plus 1 is 7. So this formula is accurate for this particular sequence. So all we now need to do is work out this missing number here. And now let's think about how we work this out. Well, the way we did this is we took the 5, we cubed it, so 5 times 5 times 5 is 125. And then we minus 1. For this one here, we did 3 times 3 times 3, which is 27, and then minus 1, which is 26. So we need to do the same process here. So we need to do 7 times 7 times 7, which is the same as 7 cubed. And then we need to take that answer for 7 cubed and then minus 1. So let's go over to my calculator and work this out. So let's have a look. So here's my calculator, so make sure you've got your graphical calculator ready. So I type in 7 cubed minus 1, give my answer of 342. So I'm going to pop that in, 342. And now we need to work out the nth term and what's going on here. So let's think about the logical process I just talked about. Well, we take whatever number is here, so this 2n plus 1, whatever number is here, we cube it. So I'm going to take my nth term from the previous sequence. I'm going to cube it, so times it by itself 3 times. And then from there, then we take away 1. Yeah, because to go from 27, 26, we take away 1. To go from 125 to 124, we take away 1. So my nth term here is going to be 2n plus 1 all cubed, whatever number this is cubed, and then we minus 1. Okay, so you can quickly check your answers. So this is the official Cambridge mark scheme, and you can see where you get the communication marks. So be aware of this on paper 6 by writing something equivalent to 7 cubed minus 1, or in this stage, 5 cubed minus 1. And you'll notice I did this in both stages of the question. Okay, on to question 2. So a grey cube now has edge length 2 centimeters. So notice this is now not equal to 1 anymore, but this is equal to 2. Of course, this is a cube, so this is 2, and this is 2 here as well. And it's still enclosed by this layer of 1 centimeter white cubes. And the calculation below gives us the number of white cubes when there is one enclosing layer. This 4 cubed minus 2 cubed. And we need to explain why the calculation works. Well, if this is surrounded by a layer of white cubes, then you're going to get essentially a 4 centimeter cube. So if I draw this over here, so this is my 2 centimeter, so call this 2, and if I add on an extra layer here, an extra layer here, an extra layer of 1 on both sides, then as I surround this shape, it's going to give me a 4 centimeter cubed. So this part of the formula here, this 4 cubed, this represents the total number of cubes. The 2 cubed, however, well, that's going to represent the amount of grey cubes, yeah, the amount of space in that grey shape. So 2 cubed is the total number of grey cubes. Notice I'm not writing an essay here. And so if we work out the difference between them, so 4 cubed minus 2 cubed, well, the number of grey cubes plus the number of white cubes must equal the total number of cubes in total. This will then give you the total number, so the difference here will give you the total number of white cubes. Okay, so you're just breaking it down for the examiner. They're checking you understand that 4 cubed gives you the total number of cubes for the whole thing. 2 cubed gives you the total number of the grey cubes, and then the difference between them will give you the layers around the outside and all the white cubes that are there. And by knowing this, we need to then move on and actually fill in our next table. So again, some of the information we already know. So we already know about the second layer. So this is going to be equal to 4. And in fact, if you work out 4 cubed minus 2 cubed, this was the formula given before. So let's just do this just so you can see this at home, what's going on. If I do 4 cubed, notice this is the cube button over here. Minus 2 cubed, like so. This gives me the answer of 56, which you'll notice is the answer already given in the table here. Okay, so that calculation we did earlier, 4 cubed minus 2 cubed, that's equal to 56. That is the total number of white cubes with a length of 4. Now notice the enclosing layers is still 1 centimeter thick, so this is still going to go up in 2s. So 2, 4, 6, 8, 10. So we're still going to have this plus 2 going on. And again, we can work out the nth term here. So we're going up in 2s. And then what do we do to 2 to get to the first term of the sequence, not the 0, but the 1, the first term 4? Well, we're going to add on 2. Again, you can check this nth term. So if we put in n is equal to 4, then 4 times 2 is 8, 8 plus 2 is 10. That works. Okay, so then we've been able to work that part out here. Now to work out the next part, let's think about the formula we use for this one here. So in order to work out 56, we did 4 cubed minus 2 cubed. So for this one here, what we're going to do is we're going to take the 6 instead. So that's the entire cube here, the entire cube with the enclosing layers, and then we're going to minus then 2 cubed, because notice that this stays the same, this never changes in size, so this would be 6 cubed minus 2 cubed, and likewise for this one here, we're going to have 8 cubed minus 2 cubed. So we're going to go over to the calculator, And we're going to work out these two different things. So first of all, we want to do 6 cubed minus 2 cubed. That gives us 208. So let's pop that in. 208. And then we're going to do 8 cubed minus 2 cubed. So let's go back to the calculator. So 8 cubed and minus 2 cubed. If we do that, we get 504. So let's pop that in as well. This is equal to 504. And now the nth term is going to work in a very similar way to what we did before. So just as a reminder, if I go back, notice what we did is we took this number, we cubed it, and then minus that cube in the middle. The next formula is going to be quite similar. So what we're going to do here is we're going to take this number, we're going to cube it. So this expression 2n plus 2, we're going to cube it, and then minus the size of the grey cube or cuboid in the middle, which in this case was 2 cubed or 8. So I'm going to put 2 cubed here to sort of keep the consistency of approach. Okay, so this is the mark scheme here, so you can see exactly where you pick up all the marks and where you pick up your method marks as well. Okay, and on to question 3. So now we need to complete the table for a grey cube of edge length 3 centimeters. Okay, so it's still going to work in the same way. So this is still going to go up by 2. So we get 3, 5, 7, 9, and 11. Because we're still adding on this enclosed layer of 1 centimeter on each side. And if we work out the nth term for this particular sequence, so it's still going up in plus 2's, then the nth term is going to be 2n. And what do we do to 2 to get to the first term here, 5? Well, that's going to be equal to plus 3. And again, we go through the same logic that we looked at in question 2. So the way we actually work out the 98 in this case is we do 5 cubed, and then we minus the volume of the cube in the middle, which is going to be 3 cubed. And if you do this on the calculator, you'll notice this does come out at 98. So using the nth term here in a similar way to what we did before, we take the 2n plus 3, we cube it, and then we minus, in this case, 3 cubed, because we have a grey cube of edge length 3 centimeters in the middle. And at this stage, this is where we're going to bring lots of what we've already done into the table below. So we're going to write down our expressions for W from questions 1D, 2B, and 3A into the table. So 3A, we got W to be this, so let's pop that in. So we've got 2n plus 3 all cubed minus 3 cubed. Let's go back to 1D and pop that in. So 1D, let's remind ourselves, was this expression. So 2n plus 1 all cubed minus 1. This typical non-linear paper, we have to go back and forward through the paper. And then 2b. So let's have a look at 2b. That was this expression here. So let's pop that in. So 2n plus 2 all cubed minus 2 cubed. And at this stage, what we're looking for is specific patterns. So notice when we have an edge length of grey cube 1, this number is equal to 1, and this is also equal to 1. If we go to edge length 2, this is equal to 2, and this number here is also equal to 2. For 3, when this is 3, this number here is equal to 3, and this number here is also equal to 3 as well. So now if we're doing it for a general length of grey cube, then what we do at this point is go, well, let's look at the pattern here. We've always got 2n. We always start with 2n. We've got plus 1, 1, plus 2, 2, plus 3, 3. So this is going to have to be e, this new letter they're introducing in e, cubed, and then minus, well, this number, it also corresponds to this. This is where the highlighting comes in useful. And this must also be equal to e as well. So now we get a general formula. So regardless of how big the cube is in the middle, we have a formula always going to work for us. And you can check the answers here as well. So you can go through what I've just discussed. And now we're on to cuboids in question 4. And this grey cuboid here has edge lengths of 2, 3 and 5 centimeters. And what we want to do is when there's one enclosing layer, how many white cubes are there? So imagine we add on a layer over here and over here, a layer over here and over here, and a layer down the bottom and a layer at the top. So the effect this is going to give us is that we have 5 centimeters here, we have an extra 1 centimeter here, an extra 1 here, so the length is going to be 7. So if we want to work out the total number of cubes, this will be equal to then 7, because that's 7 going across now. We've got 2 here, 1 here, 1 here, that makes 4, so 7 times 4. And then we've got 3 here, 1 above and 1 below, so that's going to equal 5. So the total number of cubes will be equal to this calculation here, which is 7 times 5 is 35, and then 35 times 4, that's going to be equal to 140. And then if we want to work out the grey, well, that's going to be equal to just 5 times 2 times 3, and that's equal to 30. So then the white is going to be equal to these two minus, just like we did in question 2 earlier. So we find the difference between these, and it's going to be equal to 110 cubes. And now they generalize even further. So you have a grey cuboid, has edge lengths of now A, B, and C, and the cuboid has n enclosing layers. Find a formula for the number of white cubes W. So let's think through the same logical procedure that we did before. So if I draw a cube, or cuboid in this case, so let's just draw one just so you can see what's going on. So let's call this A, this B, and this C. Then each layer we're going to add on adds an extra part there and an extra part there, where each of these is going to be n, because we did one enclosing layer, so we're going to call these n. So the length here now, in order to work out the total number of cubes, we're going to combine this together. Well, we need to work out the area of the total. So that's going to be A plus 2n times B times plus 2n, so these extra parts here. And then you can probably see C is going to work in the same way. So you've got these extra layers here, n and n. And then we need to minus the actual cuboid itself. Well, the cuboid itself here is just going to be A times B times C. So we get A, B, C. So let's just write that nice and clearly for the examiner. I like a diagram here to show exactly what's going on. So we have A plus 2n times B plus 2n, C plus 2n, and then minusing the number of grey, which in this case is going to be A, B, C. So the great thing about these investigation papers, they're building up your knowledge of the question, and it's one of these you need to work your way through so you can really understand what they're asking for here. And here's the mark scheme that you can see here as well. So where you pick up the communication marks. I kind of wrote it slightly differently to how the mark scheme does, but I'd still get all of the communication marks. And question 5 gets even more complicated. You see a 5-mark question, you're not going to get the marks for free. So a grey cuboid has edge lengths of k, k, and 2k centimeters. So let's just draw this. Notice this is a strategy I use quite often. So if I'm not sure what to do, I just start with drawing and then just go from there. So this is going to be 2k, this is going to be k, and this is going to be k. Right. The grey cuboid has 8 enclosing layers of 1 centimeter white cubes. The largest face, okay, so remember face is just like the front part or the top part, etc., of the resulting cuboid has 546 white cubes. Find the value of k. Right, so we need to focus on the largest face. So if we're focusing on the largest face, it has to have something to do with 2k and then one of the other k's. Okay, so let's then just work with this one here. So if we've got 2k, we've got 8 enclosing layers, so we've got an extra 8 over here, we've got an extra 8 over here, and we'll work with this k, it makes no difference, and so we've got an extra 8 that goes up here, and an extra 8 that goes down here. And we want to work out the area of this so-called new face. So imagine I'm just looking at the front of the shape, because that's going to be one of the largest faces. And I'm now going to generate this now new face that I'm drawing around in blue to give you an idea of how we actually increase the size of this. Right, so how do we work out the area of this new rectangle, of this new face? Well, the length of it is equal to 2k plus 8 plus 8, which is equal to 2k plus 16. So the area of the face, so I'm going to put A is equal to, well, 2k plus 8 plus 8, that's 16, multiplied by this new height, which is k plus 8 plus 8, which is 16. So the new face is going to have a area of 2k plus 16 times k plus 16. But we are told in the question that the area of this is equal to 546. And we need to work out the value of k. Now, you could use lots of different methods here. So you could expand the brackets, collect up, use quadratic formula. That certainly works as well. But one of the things I like to do on this course is show you the power of the graphical calculator. And in fact, we can actually solve this equation, 2k plus 16, k plus 16 equals 546, actually quite easily using the GDC. So let's go over there and actually work this out. So what I'm going to do, I'm going to open up the graph part of my calculator and I'm going to type in the left-hand part of that equation. Notice we have to use X here so the calculator knows what we're doing. All I'm doing is typing in the left-hand side of that equation. You notice you get something a little bit strange, which is absolutely fine. We need to use the magic button. So menu, we go to zoom and zoom fit. So if it gets stuck on the graph looking weird, then we use zoom fit. Now what we do is we type in the right-hand side of the equation. So I click the tab button and then type in 546, press enter, and notice it gives you a straight line. And in order to solve the equation, all we need to do is find this intersection point here. So we go to menu, analyze graph. This is really good practice for your paper 4 anyway. We click before, we click afterwards, and you'll see we actually work out the value of x here, which in this case is equal to 5. Now, what they'll expect you to do is draw a sketch of this, so you can show the examiner exactly how you work this out. Now, I have a slight advantage here. I'm going to use a screenshot instead. So I'm going to insert a screenshot of this, but in the exam, I draw scales. I'd actually draw in the two functions as well. So we're going to put this into our notes. So you have that there. But I would draw this sketch exactly the same way as what the graphical calculator has produced. So making sure you write in the intersection point, making sure you draw the two functions, making sure you put the scales on the actual graph that you're drawing as well. And so you can clearly show the examiner that we actually worked out the value of k in this case is going to be equal to 5. So now I just write in k is equal to 5. You'll see on the mark scheme here that this is the first method, so I've gone through the first method here, where I've drawn a sketch of my quadratic, and I've actually worked out using the horizontal line at 546 to work out the answer of 5. And notice I get all the communication marks from the previous parts of the question. Of course, you can always solve this by, as I mentioned here, quadratic formula. Factorizing it, yeah, might work as well here. So you can certainly use that method there as well. But please do get used to using your graphical calculator. And if you need any more Paper 6 practice, then do click on the video you see in front of you, because there are tons of Paper 6 videos that I've done to prepare you for your exams.